Okay, so welcome back. I'm gonna turn on this thing. Yeah, welcome back, everyone. I was really very pleased to go around the different breakout rooms and see how every one of you is trying to code this. Very nice. And actually, it gave me some ideas also to discuss here in the main room. Let me try to solve this with you guys here. So as we learned, this has to be function. Then you need to give it some output out of it. So let's say I'm gonna take x, y, z, and distance, which is d, as an output. And let me call it cylindrical to, I can even type it this way, cylindrical to cart, cylindrical to Cartesian coordinates. Some of you, they wrote the word cylinder, and MATLAB gave them an error because cylinder apparently is something related to built-in functions. So they needed to avoid the name cylinder. They can call it my cylindrical, for example. Here I'm calling it cell to cart, or I can even call it my cell to cart, And as an input, it's gonna take R, theta, and what? And z. Now, some of you, and of course, when I save it, I need to call it cell to cart. So I have to save it with this name exactly. So I'm gonna save it this way. Some of you expected this function is gonna interact with the user, and they went ahead and said, hey, R equals input of, please enter the value of, R. You don't need to do this. Guys, functions, they don't interact with the user. The user calls them right away without interactions with this function, without talking to the function. And the user should know what to give to the function. So they should know that they need to give it R, theta, and Z, okay? So let's start coding things. So X is R cosine theta. I will make another comment here. Y equals R sine theta. And then Z is Z, so it's not going to change. So there's nothing to do about it. While D is a square root of X squared plus Y squared plus Z squared. That's it. Guys, this is a very naive writing. In other words, it's very simplistic, no complications, no taking care of every little detail that some of you already thought about inside the breakout rooms, which we will try to address some of them. But let's test it with this symbol, symbol format. Let me clear all and CLC. Guys, when you call a function, you need to copy all this and paste it here because you wanted to output X, Y, Z. Some of you didn't actually write this stuff. It's gonna work. So they typed the name of the function in the input. It's gonna work. It's gonna give you one of the outputs. Here you want 4 outputs. Typically, it gives you the first output, which is X. But here you wanted to give you X, Y, Z, and D, right? So because of this, you need to type X, Y, Z, and that equals the name of the function. You can give the values here inside these things, inside this bracket. So R, let's start with R equal 5. Theta, let's use theta equal pi, okay? Because it's going to be used in radian. And Z, I can use whatever Z I want. Let's say 10. Let's see what's going to be printed out. So X should be R cosine theta. And if you remember from your basic trigonometry, cosine pi, which is cosine 180, is -1. So that's why it's giving you X equal -5. So it seems to be working fine. Y cosine 180 is, sorry, sine 180 is 0. So that should be 0. But that's something we talked about before. MATLAB is giving you a very, very small number, close to 0, in fact. This is 6 to the power 10 minus 16. it's like 0.000000016 times, right? So it's a very, very, very small number. And that's something called round-off error. It's very common while using computers. And sometimes it leads to issues in some engineering calculations. But this is really beyond the scope of this course. This is usually something is addressed in numerical methods courses. And they can tell you techniques trying to reduce round-off error as much as possible. But it's good that we faced it here in this simple exercise. And then Z is not changing, it's 10. And then if you calculate the square root of -5 square plus 0 square plus 10 square, and then you take the square root, that should be the distance. Okay. It turns out that our function is working, but we can make it more beautiful. How do we make it more beautiful? First of all, we can make it to check whether the user wants it to give the angle in degree or in radians. So for example, I can put here, there are many ways to put this. I'm just going to show you one way. I'm going to give a variable here I'm going to call it degree or rad, okay? And that degree or rad, why MATLAB is, maybe, I don't know why MATLAB is unhappy with this name, but let's call it this way, dig or rad. So if dig or rad equals 1, I'm gonna write a comment here. Actually, let me, because the name is good, I'm just trying to choose a good variable name. Let's call it this way, dig or rad, or maybe dig rad. So degree or rad, okay, dig rad. MATLAB is unhappy about it, so maybe I'm gonna call it my dig rad. So if my dig rad equals 1, that means the user inserted the angle in degrees. And in this case, instead of x equal r cosine theta and y equal cosine r sine theta, I'm going to put a d here, because that means that the user inserted the angle in degrees. And I'm going to put an end f here, end f statement. Okay. Suppose that the user, this variable, the user made it 0. Then my function should understand that the values given are in radians. And I'm going to put an f statement here. If my dig rad equal 0, you notice I'm putting two equals here, right? That's what we learned about if statements. Then the user inserted the angle in radians. And in this way, I don't need to put the d next to the cosine and sine, because automatically cosine and sine, they use the angle in, in radian, right? Honestly, when I prepared this exercise, I didn't have this idea in my mind to present it here in this room, but one of you asked this question: how do I address the case if the user is gonna give me the angle in degree or a radian? I can write a documentation for this here. The variable or the input, my underscore dig rad, has to be 1 if the user plans to give the angle in degrees. However, it has to be 0 if the user plans to give the angle in radians. That's it. That's basically one way to do it, right? One way to do it. In fact, let's run this code now. Now I increased the number of inputs by 1. So I'm gonna, let me CLC here and maybe clear all as well. I'm gonna use the previous case. except I need to give the angle degrees. So I'm going to put 5. And instead of pi, I'm going to put 180. And because there is a new input, which is my digrad, since I inserted the angle in degrees, I should make this variable equal 1. This way, the statement is going to go to this block here. Okay. So now if I hit enter, it's going to give me exactly the same answers, right? Because it actually managed to make this 0 as well, which is good. So that's one way to address this thing. So guys, the bulk of the code is there, but you can keep improving it. And that's usually why you see when there is a software release, sometimes they say this is version 1, version 1.2, version 1.3, and maybe version 2, version 3, because they keep modifying it and make it better and better and faster, you know. For example, if you want me, how can you modify this and make it better code? Maybe instead of 2 F blocks, I can make it 1 F block, but instead of F, I'm gonna put else F, you know. That could speed up things a little bit. Instead of having 2 F blocks, it's just 1 F block. What else? How do I improve my code? Maybe I need to check that R is greater than 0, because you remember we learned from calculus that R is always greater than 0. Maybe I should checking that the input radius is positive. So if R is less than 0, I should give an error message to the user, error. And you know, what's the error message? Make sure the radius is positive. And I can make an end here. Let's stop here and let me run this code again. Let me first CLC and clear all. And let's try to test it together. So R is 5, theta is 180, and no, R is 5 is okay. I want to make it a negative number. Let's make it minus 5, 180. Z is 10, and it's my degree. I'm gonna put it 1. So basically, treating the angle in degrees. So do you see what happened here? It gave me an error message. So make sure the radius is positive. It's basically displaying the error message here. And the user should, you know, get alerted and go back and change this to positive 5, something like, you know. Guys, I can keep improving this. I can do a check on the angle. I can do other checks, you know. That's why developing a good software takes time. You start with a primitive version and gradually make it better and better and better and better. Any questions before we take a short break? I'm going to look at the participants here. Just unmute yourself and ask. Feel free to share a screen if you have a question on your screen. Any, or just type in the chat if you wish. That's also fine. Okay. Oh, yeah, there is one here. I am getting an error message. Would you like to share a screen? Hannah, would you like to share a screen with us? Yes, please. I'm going to stop here. Yeah. So, not, yes, that's the not enough input argument, because when you called the function, you didn't give it any input. And in fact, you didn't even request an output from it. So I would rather recommend here, Hannah, that you bring your mouse and copy this whole block. Literally, copy this whole block. Yes. And paste it in the command window. And yeah, let's delete R. Let's delete the R here and put some value for it. Anything, any value for R. So okay, so the radius is 1, and give some value for theta. Are you planning to give it in so you are planning to give it in radians? Because you are planning to give it in radians, the last input, which is my underscore degrad, has to be 0 according to the way we coded it. Perfect. And that remains the Z. Just give some value for the Z, whichever you. Okay, so let's test now. Can you hit? No, you don't hit run. You just hit input. So you, sorry, enter. Now, yes. So can you scroll up? So the X is -1, which is expected because it's R cosine pi, and cosine pi is -1. The Y is almost 0. It's not exactly 0 because round of error, which is okay. We know this. Z is 8, and that's the distance. So Hannah, it seems it's working. It seems it's working out. Perfect. Any other questions here? Don't see anything. Perfect. All right, guys. So let's take a break, 10 minutes. So we will be back 37. So it's 27 now. Let's get back at 37. Thank you so much. Talk to you in 10 minutes.